My name is Ashish Mahabal, and we'll be continuing with R and looking at ggplot. So much of this material is taken from Hedley's book by the name ggplot2. We start with the anatomy of a plot. Last time we saw a little bit of what grammar of graphics is. So this shows graphically how the elements in the grammar of graphics can be brought about. So you see at the top that you have mapping of variables to aesthetics. So overall what happens is that you have a data set, a data frame as we saw, and a certain set of mappings, one or more. And then there are multiple layers. And for each of those layers, you again have some data, which is very likely a subset of the original data that you have, some mapping, and associated with that a geom and a stat, and a position where that particular layer or subset should go. Then for the overall plot, you have got one scale per mapping. And then you have got a coordinate system and a faceting specification. So the coordinate system would take care of whether you have log scale or linear scale and so on. And faceting specification is where you will know what kind of categorical variables are being used to separate the data sets into either sublayers or subplots and so on. So this overall picture is very good for allowing you to debug your plot. So if you are trying to build a plot using layers and you are not getting what you want, then you can ask yourself whether you have the correct geom, whether you have got the correct stat, and how they should be interacting with each other, where should the position be, whether that is correct, is one of your coordinate system wrong, and so on. So by just keeping this figure in front of you, many times it's fairly easy to debug what is it that you want to look at. So it is again a summary of what a plot is made of. Again, there is a data set, a set of mappings, we saw a geom set and so on, right? And so example of scale can be this. It can be a continuous variable or a discrete variable. Remember that discrete variables are the ones that we use for doing categorization and faceting, but even the continuous variables, you can convert them using the as.factor function into a discrete variable and use that as well. So what is it that actually happens when you make an object? We saw that you can assign your ggplot command to an object called P and not have anything rendered immediately onto the screen. So what is it that you can do with such an object? If P is the object that you have made, then you can print it. And this is something that happens quite automatically if you are not inside a loop. So if you make this object and simply say P on the command line, it's going to do the printing of P. Then you can save that object. So ggsave will write out an image for you. So rather than going to the screen, this is what will allow you to write it out to the disk. The other interesting thing is summary. It is, as before, overloaded, and with this object P, if you simply say summary with empty parenthesis, then you are going to see what is hidden in the object, and we'll do that to one of the objects. Similarly, save, instead of ggsave, is going to save the object itself. Rather than as a plot, the object as a R object will be saved to the disk, which you can reload later on. So let's look at the summary of the P object that we have defined at the top here, where we are again taking the CRTS data set and simply plotting amplitude versus standard deviation there and factoring it into different colors by the object variable. So you see that though we have used only amplitude and standard deviation in the plot, the object knows about all the variables that are in the data frame. So all of them are listed here. It also tells you what is the size of the data frame. There are 16, 19 rows and total 26 variables. And then it tells you what the mapping is, what the X is, what the Y is, and what faceting has been used here. Now, in addition to P, if you were to do a geom point, that is do P plus geom point and look for the summary of that, you will additionally see what the stat identity is, what the geom point is, and what the position identity is. In this case, we have not specified that explicitly, so we get mostly nulls and false and so on. But all that information in principle is there. So that is another useful thing about the layering aspect. You can keep on piling up various layers into an object, and then those layers become available to you in various different ways. So you can say save P and file name to save the data file, and then you can reload it again using the load command. And then after that, you can add various layers to that. So that's a very convenient thing to do. This is another way, example of adding layers. So we use here ggplot2, and we are using a slightly different set here. This set is called diamonds, and it is available with the ggplot2 library. So if you have started ggplot2 library, the data diamonds will allow you to access these commands. So here we take that set of diamonds and use the aesthetics of number of carats in that and price, and then use a cut for the colors and do the plot there. And so now if we do a geom of point there, you can add that as a layer. Notice here that we have used slightly different syntax. Rather than saying geom_point, we say that we want a layer and then geom equal to point. Now this is where you can start combining different stats in geoms effectively. So next what we are saying is that we can simply plot diamonds with aesthetics of x equal to carat, so it's simply going to use that particular variable. But then to that p, to that object that we just defined, we can add a layer with a separate geom and a separate stat. So when you plot a histogram, what is it that is actually happening? You bin the data, so that is what your statistics is. And what do you actually plot? You plot bars of it, so that is what your geom is. And so this pairing is automatically done for a histogram. And then when you say simply p, that is what is going to appear for you on the screen. So here is an example of a histogram as it comes out of ggplot2. In this case, we have used a bin width of 0.3. We can, of course, use quite interesting and sometimes useless stats or geoms with a particular data set. Here I am simply listing a few different geoms like bar, box plot, contour, line, point, step, text. There are a total of 29 of these, and just for fun here I have used the geom of polygons on this particular data set. This is the same data set that we used in the last lecture, the CRTS6 class set, and then you can see that it doesn't make sense, but the shape is roughly the same as what we had got when we had plotted x versus y. Similarly, there are 15 different statistics. I have listed a few here. The book and various websites will have more. We'll also have it on the website of the course. So we can have contours there, we can have density 2D, and that is what I have used here. I have used density 2D, and I have said that let us use a bin width that is very small, only 0.01, and that is why you see that towards the lower part of XY area, you see that there are very dense contours. As you go out, there is less density, and you can see that in the contours there. So some additional points. You can have the ggplot with geom point, as we saw. When you want to add aesthetics, you can give that as arguments to the geom point too. So if you say geom point color equal to red, then the points are going to be plotted as red. Similarly, in the layers, you can have various smoothing things. So here I've shown that for the point method also, you can provide method equal to lm as your layer, and then smoothing can also be done in addition to that. Similarly, you can do scales and axes. We have not seen an example of that, but that's homework. You can take a look at that. We are adding that as additional layers. So when you say geom point, it's going to take whatever the default scale is. But in addition, you say that, oh, I want log scale for x. It says, sure enough, add that as a layer and you get that. In this particular example, we have added both x and y as log scale. Then similarly, you can add plot options. So you don't have to be stuck with the defaults. The defaults are reasonable, but normally for making plots into publications, you want the axes and labels, etc., to be much bigger. So you can specify all of that as an additional layer simply by using the command called opts. Here I've specified, for instance, what the title should be and what the aspect ratio should be. And you can add various other commands with that. So the homework with respect to this is take the data set that we have provided, and we saw examples using only two variables, amplitude and standard deviation, but there are several other interesting variables. Try to see if you can use them and separate them in many different ways. This, what we have covered here, is fairly basic graphics. We were not trying to visualize in any very different or specific way how to go about things. We were looking at only what is available. There will be additional modules in the course where you'll be looking at visualization, how you should be plotting the data, etc. Thank you.